So since there's not a specific topic you guys want to go over, I'll just go over some quick questions. I won't take much of your time since you guys do have a midterm tomorrow. All right, so let's start with the first question. Which of the following molecules is polar? Does anyone know the answer to this question? Okay, let's solve it together.
BEH1? The third one?
BEH2, yeah.
So you guys are saying BEH2?
Yes.
Okay, no.
Yes.
I'll explain why BEH2 is wrong. Does anyone have another answer for this question?
CO2.
First one, CO2.
No, I think
CO2?
it's SO2.
C
So you guys said this one, and this one, basically, right?
Yeah.
Okay. So let's go through all of them one by one. So let's start with CO2. Does anyone know what's the geometric shape of CO2?
Linear.
Linear. If we have a linear, is it going to be polar?
No, they'll cancel out the O's.
Exactly, because it's going to be a straight line, right? We have one going this way and one going this way. If I'm pushing to the right and I'm also pushing to the left, is the object going to move in general?
No.
No. So therefore, this one is not polar, right? For the second one, none of you said this was the answer, so at least you guys know that part. I have two atoms which are the same. There's obviously going to be no polarity between them, right?
Yes.
Yes.
Okay. BEH2. What's the shape of BEH2?
Bent.
It's bent?
Wait, BE has two, like it's group 2, right?
Mm-hmm.
Yeah, so it's linear, I must say.
It's also going to be linear. It's going to form two bonds like this. So if it's linear, is it going to be polar or is it not going to be polar?
Not polar.
Non-polar. So therefore, BEH2 is not the answer. Do you guys get why BEH2 is not the answer?
Yes.
Yes.
خلاص. Now we go to the SO2, which is the third answer you guys gave me. When SO2, does anyone know the shape of SO2, the geometric shape?
Bent.
Bent. Does everyone know that, or does somebody want me to explain why it's bent?
Could you just go over the bonds?
Okay, so this is going to be the structure of SO2, basically. And then it has a lone pair. Let me draw it more properly. Do you get this, or do you not get it?
Yes.
Okay, so if I have one lone pair, no matter what, when I'm seeing if something is polar, there's two things I usually look for. Okay, it's symmetry and lone pairs. Okay, so for every time I see that there's a lone pair in the molecule, I know for a fact that this molecule is polar, no matter what. Okay, because we know that the lone pair has a greater effect, right? It has the lone pairs will make the molecule polar on the side of the lone pairs. Okay, do you guys get that part?
Yes.
Okay, now for the symmetry part, we're going to talk about the CF4. Okay, it's obviously tetrahedral, right?
Yes.
So if it's tetrahedral, it's going to be polar or non-polar?
Non-polar.
Non-polar, because everything cancels out, right? But if I give you guys something like this, for example, is this polar or non-polar?
Polar.
Polar, because I have the Cl here. It's not symmetrical anymore. But this one, for example,
Non-polar.
Non-polar.
It's also non-polar because this cancels out each other and this cancels out each other. Okay, so whenever you're seeing if something is polar, you look at two things: symmetry, and if all the bonds attached to all the atoms attached to the carbon are the same, and if there's a lone pair present. Okay, you guys got this question?
Yeah.
Okay. All right. Next question. Does anyone want to answer this question?
Sulfur.
Sulfur?
Wait. Not sulfur.
Not sulfur? What then? I'll give you guys an easy way to solve
Fluor.
Fellow,
Which one?
fluorine.
So you guys are saying fluorine, right?
Yes.
Yes.
Okay, let's look at the periodic table. Now, I don't know if you guys remember, but we can classify the periodic table into blocks, right? And we have an S block, a P block, a D block, right?
Yes.
Okay, so my S block is which groups?
1 and 2.
1 and 2.
1 and 2.
Yeah.
So this is going to be my S block. And my P block is where?
From 13 to 17.
Exactly, okay? So if I go back to the question that I had, I can see that it ends with
3b5.
P. So the atom that I'm going to choose is obviously going to be in my P block, right?
Yes.
Hello. So is potassium in my P block?
No, it's in the first S block.
It's in the S
It will
block.
be chlorine.
Chlorine, exactly.
Yeah, chlorine. في period 3.
Yes, exactly. So other than the P, I saw that it's also period 3. Okay, so two things to make it easier for you guys, because obviously in the midterm you won't have time to count every single thing. Obviously, you look at the number and then the letter. The number represents the period, the letter represents the block. Okay, so everyone got why the answer is chlorine?
Yes.
And you guys now know how to solve it really quickly. المهم. So now let's go to question 3. Determine the molecular shape around the central atom and classify the molecule as polar or non-polar. So how many bonds do we have here?
3.
4 bonds may have.
4 bonds, right? But 2 of them are in the same direction, right?
Yes.
So technically we have 3 bonds. Okay. Now in this case, is it polar or non-polar?
It is polar.
Polar. And why is it polar?
Because it's unsymmetrical.
Exactly, بالضبط. Okay. So everyone got this question?
Yep.
All right, next question. This question, they're probably going to get at least one question that's going to ask you which one is drawn correctly. So I would recommend to go over the principles that you need to know when you're drawing the electron configuration. So basically the question says, which one of the following is the correct electron configuration for a ground state nitrogen atom? Now, what does it mean when I say ground state?
It's not excited.
Exactly. Not excited. So the charge on the atom is going to be
Neutral.
0. It's going to be 0. It's not an ion. It's not a cation. It's not an anion. Okay. So here it said nitrogen, right? So nitrogen, how many electrons does it have? 7. Okay. So I have 7. And which period is it in?
2.
Period 2.
2. And which block is it in, Kaman?
P block.
P block. So it's the second period and it's P block. So I'm going to end up with 2P. Now, is there anything wrong in the first row right here? In the first column, sorry?
Yeah, the last one has
Last one. Both of them are pointed in the same direction, right?
Yes.
So therefore, this is definitely wrong. So I can ignore this part مرة واحدة, right?
Excuse me, what does it mean when it points into both same direction?
You want to know why it's supposed to be in the opposite direction?
No, I mean, what does it mean when they point in same direction?
When they're in the same direction, this is wrong. They're supposed to be in the opposite direction.
Always in opposite.
Yes, they have to be the opposite.
Okay.
Okay. So, like we said, the last option is wrong, so I'm going to ignore it. Now in my second column right here. Sorry, in my second column, is there anything wrong here?
The third one,
Third one.
Third one, why?
both in same direction.
Same direction, so we cancel this one out. Now for this part, the last one. We're looking at only these two now, because we canceled the others. Which one would be correct?
First one.
The first one, because when we are writing the electron configuration, we don't go 2 by 2. We go 1, 1, 1, like that, okay? Please don't mix up know how to write the electron configuration, because they can trick you with these questions, okay? Has everyone understood this part? Okay.
Yes.
All right, now question number 5. In which of the following electron dot formulas is the formal charge incorrectly assigned? Does anyone here not get how to do the formal charge questions? Bob, can somebody tell me what's the formula for formal charge?
It's like valence of the atom
Okay,
plus, or is it minus? Not plus, صح?
it's minus.
Oh.
It's okay, minus.
And then in between brackets, I think you add the lines plus the dots.
The bonded plus the
Non-bonded.
Divide
non-bonded.
by 2. Yeah.
Divided by 2. Which one do we divide by 2?
The bonded, I think. Because the bonded, like the electrons are to two atoms.
Yes, exactly. So the unbonded plus the bonded divided by 2. Okay? Hello. So do you guys want me to go over it and solve an example, or do you guys understand this part?
Can you go over, please?
Okay. Let's start with the first one, for example. Let's do the formal charge of carbon, okay? So what did we say the formula was? First, we're going to start with the valence electrons. How many valence electrons does carbon have?
4.
4. Okay. Then, how many unbonded electrons does it have?
0.
0. And then, how many bonded does it have?
1.
How many bonded electrons? I'm looking at the carbon here.
Oh, sorry, carbon.
Yes.
4. We have, sorry, 3.
No, it's how many electrons, not bonds. How many bonded electrons?
How many bonded electrons?
I have 2 here, and then I have 4 here, صح?
Mm-hmm. Yeah,
Do you understand where I got it from?
Yeah. So
you
each bond has 2 electrons, and
it's the same as if I drew it this way, basically. I drew H, and then I did C, and then like this. It's the same thing as this, basically. It's just here I'm showing you the singular electrons, and here I'm just showing you the bond. Did you get it? Well,
yes.
Okay, so how many bonded electrons are there?
6.
6, and then I divided by 2. Okay? So here the answer would be +1, right? So far, this one is correct, right? For this case, obviously you're going to have to do for every single one of them because they're different, right? Because here I have 6 electrons bonded to it, but for example, here I have a lone pair. Is it going to be the same, or is it going to be different?
No, you have lone pair. You would one.
So will I have the same formal charge as this one, or will I have a different one? I'll have a different one, okay? So let's continue with this example. Let's find the one for nitrogen now. How many valence electrons does nitrogen have?
5.
5. And then how many non-bonded?
4.
4. And then the bonded are also
4.
4. We divided by 2. The answer here would be -1. Is this also correct? Yes, because here it says minus, so it's correct. The H here is going to be the same for all of them. Again, so it's going to be, you don't really need to do it for the H because it's going to stay the same for all of them. But do you get how we solve the formal charge? For the person who asked me to solve it.
Yes, yes. Thank
Do
you.
you want me to continue solving, or do you get the idea?
I got it. Yeah.
Okay, خلاص. All right, now let's go to the question number 6. How many sp2 bonds are there in the following substance? When we say an S bond, we mean that the carbon has, when we say S bond, we mean that there's only one bond, right? And who can only have one bond? What atom can only have
Hydrogen.
Hydrogen, exactly. So no, in this case, I'm going to look for a hydrogen, right? There has to be a hydrogen present in the bond. And my sp2, it means my carbon has to have how many bonds?
2.
sp2 3 bonds.
3 bonds. Why? Because look, S is 1 bond, and then I have 2. So 1 plus 2 will give me 3. Okay, you guys got the idea?
Yes.
Okay, so now let's go and see how many sp2 bonds are here, okay? So let's see, this carbon right here, how many bonds does it have?
1.
4.
4. So what is it going to be? Is it going to be
sp3.
sp2, all right, sp3, right? So here it's sp3. Is this what I'm looking for?
No.
No, so I can ignore this one. Now here, this carbon right here, how many bonds does it have?
sp2. 3 bonds, sorry.
3.
3 bonds. Do you guys get why it has 3 bonds and not 4 here?
Yes.
Okay, so
SB2.
this would be sp2, right? Hello. sp2. This carbon is sp2. صح? طب, isn't there a hydrogen here? And the hydrogen is what?
S.
S. So do I have my first sp2 or do I not?
Yes.
Yes.
I have. So this is my first one. Now let's go here. What is my carbon going to be?
sp2 s.
SB2 S.
sp2, and then I have the hydrogen, so it's also S. So this is my second one.
Yes.
Here, my carbon is what?
sp3.
sp3. So I'm not going to look at it at all. Well, my carbon here is what?
sp3.
sp3. So I ignore these. And this one right here?
sp. There are 4 bonds, right?
Is it 4
sp3.
bonds?
1, 2, 3. Yeah.
Only
Is it-
sp2.
without
sp2.
SP. Without
It is
S.
sp2. Yes, you're correct. It's an sp2, but I don't have a hydrogen for it to form an sp2s bond.
Yeah.
Okay, because I have here this methyl group did not, if there was no methyl group and there was an H, then this would be an sp2s sigma bond, right? But here, since we don't have it, it's just an sp2. sp2, and this one is what? This one right here.
sp3.
sp3. So this one, I'm going to ignore it. Here, the carbon is what?
sp2.
sp2
S and SB2.
sp2, and I also have a hydrogen, so it's
s.
It's
S.
Yes.
So this is my third one, and then this one is
sp3.
sp3. So in total, how many sp2 bonds do I have?
3.
3. Do you guys all get why it's 3 and not 4?
يعني ما نسوي سيبريت حق الاس والاس بي 2
Yes.
قدرنا الاس بي الرابعة اللي وجدناها
هاي.
إيه.
أيوة.
ما نحسبهم؟
لا هاي ما نحسبها. احنا we're looking for an SP2 صح؟
نعم.
أيوة. طب I have an SP2. Right? I have an SP2 بس هاي this is a CH3 group. وإحنا at the beginning what did we say? You know the only one that can have an S bond is what?
هيدروجين.
Hydrogen. في hydrogen هون؟ ما في
ما في.
hydrogen هون صح؟
نعم.
فهاي تعتبر SP2 SP3 bond مش SP2S bond. فهمت ولا عيد؟
فهمت.
متأكد؟
نعم.
خلاص. Anyone has any other questions? Okay, let's go to the next one. This is another example of the SP bonds. So now here we're looking for SP3 bonds, right? In ethane. So let me draw. Do you guys want me to draw out ethane in the skeletal formula like this or in the structural formula? Skeletal? Okay, so ethane. ما هو ethane is gonna be a line يعني. Let me draw it like this. Okay. So again, we said who can have an S bond?
Hydrogen.
Hydrogen. Okay. And the sp3 bond, the carbon has how many bonds on it?
3.
No.
4.
4.
So you have 3 and then the S
3
is
and
1.
S1.
Exactly. So we have 4 bonds on the carbon. Okay. So let's right away we know in all the hydrogens are S, right? Hello. But my carbon here, what's the hybridization here?
sp3.
sp3. So how many S1, S2, sp3 bonds do I have? I have one here. I have one here. I have one here. صح ولا لا?
Yes.
You guys got that part?
Can you repeat what is that?
What is what?
What was your question?
I said this is sp3, right? Well, this is S.
Yes.
I asked
Yes.
in this carbon how many around this area basically here. How many 1s, 2 sp3 bonds do I have?
Yeah.
I have 3, right?
1, 3. Yeah, 3.
1, 2, 3. Now let me go and do the same thing on the other side. This carbon is also sp3, right?
Yes.
So how many 1s, 2 sp3 bonds do I have here?
3.
1, 2, 3. But this bond here is what? Between the two carbons. This one is what?
sp3.
sp3, sp3. So do I count it?
No.
No. So how many do I have in total?
6.
6. Okay, did everyone understand why it's 6? Okay, let's go to the next question. So the number of possible acyclic hydrocarbons with the molecular formula C4H6. Okay, what does acyclic mean?
Non-cyclic.
Not cyclic. So I'm not forming a shape, صح?
Yes.
Okay. I'll draw them out for you guys here. Basically, what do you guys think the answer is? Does anyone want to try or no? Or do you guys want me to solve it right away? خلاص, I'll solve it right away. Just so I don't waste your...
Have a triple bond.
Okay, so we can have a triple bond. So I have how many carbon? I have 4 carbons, right? 1, 2, 3, 4. Okay.
Yeah.
You said I can put a triple bond. Where can I put the triple bond?
First or in second carbon?
Hmm?
And first or second carbon?
So let's start with the first one, okay? So if I put in the first one, I'm gonna have here an H, right? صح
Yes.
ولا لا? Okay. Then here, do I need to put any H's on the second carbon?
Ah,
No.
No, because it already has 4 bonds. And the third carbon, if I form one bond here, well, how many H's do I need to put on the second carbon?
2,
2,
2. And then the last carbon, how many H's?
3.
3.
3. Do I have here 4 carbons and 6 H's?
No.
So this is one of them. Can we do it in another way? Can I put the triple bond somewhere else?
Yeah.
In the middle?
In the middle. So like this, right?
Yeah.
How many carbons, how many hydrogens am I going to put in this one?
3.
3. Okay. And then in this carbon, how do I put hydrogens or do I not put hydrogens?
No. It has
No.
4.
Exactly. And in this one, the next one?
No.
No.
And in the last one?
3.
3.
3. So this is my other one. But if I tell you guys,
2 double bond.
if I give you this, for example, is this going to be another isomer or no?
No.
No, it's the
this
same
is
as the first one.
Same as
The
the
same
first one.
first.
It's the same as the first one, so I can't do that. So somebody said something. I didn't hear you.
Yeah, 2 double bonds.
2 double
No.
bonds.
It is C4H10 here.
Where?
This is only for alkyne.
No, you can do double bonds. I'll show you here. Look. So somebody said I can do a double bond. Where do you want me to put the double bonds?
First and second.
Here, like this?
Yes.
Okay. How many hydrogens can I put in this one?
2.
2. Okay. And then here, do I put any hydrogens?
No.
No. And do I put any hydrogens here?
1.
1. And then in the last one, how many do I put?
3.
3. The person who said it only happens in alkynes, do you get how I turned it into 2 double bonds or no?
About the formula is for alkyne here.
The C4H6?
Oh, it is C4H6. Sorry, I said C4H10.
No, C4H6. When they don't specify what type of hydrocarbons they want, it can be anything. You just need to make sure that you have the right number of carbons and hydrogens, okay?
Okay.
Okay, can I make another isomer or can I not?
Yes.
Okay, how can I do it?
First نحط الدبل وفي النهاية نحط الدبل.
Exactly. Well, how many carbons am I going to put in the first carbon?
2.
2. And then in the second carbon?
1.
1. My third carbon?
1.
And then in my last one?
2.
2. So you guys saw how I made acyclic hydrocarbons with the same molecular formula?
Yes.
Has nobody has any questions?
Can't you make like a branched propene?
You want me to make propene?
Yeah, propene, but like 2-methyl propene, maybe.
Okay.
2-methyl 1-propene.
So, okay, tell me where do you want me to put the bonds?
So triple bond in the first carbon, okay,
Mm-hmm.
and just a single bond to the second carbon, to the third carbon, and like a branch.
Branch from which carbon?
Second one.
Can I do this?
Oh no, sorry. Yeah, you can't.
Okay, so always draw it out. Like my colleague said, Lore, draw it out and it will save your life, okay? Any more questions, guys, or do I move on? Okay, I'll move on. So according to the VSEPR theory, a molecule with 3 charge clouds, including 1 lone pair, would have what shape? Who knows the answer for this one? Do you guys understand
Is
the
it
question?
bent?
Yes, the answer is bent. How do you figure it out?
Because it
Because
has a
two
lone pair.
bonds and one lone pair.
2 bonds and 1 lone pair, okay? Sometimes the wording may be confusing, but so make sure you read the question properly. Did everyone understand why it was bent?
Yes.
Yes.
خلاص. Okay, next question. Question number 10, formal charges. Do you guys want me to go over this again? Formal charge? Well, you guys already understood from the last question.
No need.
Yes.
What?
No need.
No need? Oh, خلاص, okay. Yeah, the last question and then you guys can go. How many bonding electrons are shown in the Lewis structure for the bicarbonate ion? Who can tell me how the bicarbonate structure looks like, first of all?
Bicarbonate.
Yes, bicarbonate. So this is basically it's going to be CO3H in other words. And then there's a minus on one of the O's.
Oh, okay.
Does anyone know, or do you guys want me to draw out for you?
Draw out, please.
Okay, so this is how the structure is going to look like. Okay? Am I missing any lone pairs or no?
Minus.
Am I missing a lone pair or no? When?
Oxygen and up.
Okay. Be careful when you're drawing the structures. You make sure and know you're writing the structure correct, okay? So how many bonding electrons do I have? When I say bonding, what do you mean by bonding electrons?
5.
The one in the lines, but it says electrons, so we count them not as pairs. Yani we get 10 in total.
Exactly. I have 5 lines, so that means I have
10 electrons.
10 electrons. Does everyone understand how to solve this?
Yes.
All right, guys. So that was the revision for chapter 1. I hope this session was useful for you guys, inshallah. Sorry it took quite some time, but alhamdulillah, inshallah, it was useful. And good luck with your midterm and your chemistry midterm.
It was
Thank you so
useful. Thank you.
much.
It was very useful. Yeah. Thank you.
Thank you guys for coming.
يعطيكم العافية.
الله يعافيك. Good luck, guys.
Thank you for your time. Bye.